My name is Minko Gechev. I lead product and developer relations for Angular.
And I'm Jeremy Elbourn. I'm the engineering tech lead for Angular.
So, Jeremy, I've been hearing the community talking about this Angular renaissance. And I know we have a lot of talented people on the team. So have you been getting more into literature and art?
You know, Minko, I think people are saying that because we have been shipping. And what have we been shipping? Well, we have shipped deferrable views.
That's right. We published the RFC right here at Conf 2023, wondering if there is something that is going to happen this year on stage.
And that wasn't the only RFC we published during the Keynote last year.
Yeah, we published the RFC for control flow, and we actually shipped it since then.
We recently shipped experimental support for Material 3 in Angular Material.
And there is a great There is also a great blog post by Miles on the Angular blog on how you can take advantage of it today.
Yeah. And, of course, we have shipped a slew of new signal-based APIs for components and directives.
And there is so much more. The list goes on and on with features in the Angular CLI, in Angular DevTools, components, documentation. There are new lifecycle hooks, and so much more.
Yeah, and everything that we have been shipping has been in service of our mission to help developers like you deliver web apps with confidence. And we're doing that by making it easier to build faster apps. We're doing that by giving you tools to build apps faster. And we're doing that by keeping the platform as stable and reliable as possible.
Now, we're introducing all these new features, and they all step on a very solid foundation. Alex will talk more about this in his talk, Angular's DNA, at 3:30 on Thursday.
Yeah, Alex will be closing out the show, so make sure you get over to that one. Today, though, we are going to highlight the new features we've shipped over the past year, show off some projects that we're currently working on, and talk a little bit about what we see on the horizon.
But first, we're going to tell you some exciting news about the future of Angular. So, as most of you know, the team has spent a lot of time working on signals. And it was just less than a year ago when we published the RFCs on Angular Signal. We got incredible community response, and we received over 1,000 comments across the RFCs on signals. So clearly there was a lot of community interest around them.
But it turned out there's more interest in signals than just from the Angular community, and something that we didn't actually predict happened.
So most of you may not know this, but inside of Google we have one more framework called Wiz. Wiz is not an open source framework. It is internal to Google, and it is also very tightly coupled to the internal Google tech stack. It is also very different compared to what you're used to from the open source community. Wiz is also hyper-focused on performance above all else, and this is why many Google flagship products are using Wiz, such as Google Search, Google Meet, Photos, Google Play, and more.
Yeah, you know, Google stuff. So Angular and Wiz have both existed in some form for over 10 years. And in the beginning, the types of UI that developers would build with them were a bit different. Wiz applications tended to be more consumer-focused, especially for products that were extremely latency sensitive. And Angular applications tended to be more kind of highly interactive, a lot of overlap with what people would commonly call enterprise or business-focused UIs.
But over time, something we started noticing, the lines between these two different types of UIs, they started to blur. Google developers working with Wiz wanted more features like Angular, and Google developers working with Angular wanted more features like Wiz, and that was not only Googlers, but also developers in the community. So it became clear that these two different frameworks were actually converging on very similar ideas. And people at Google were asking, why are we duplicating so much work?
And so last year, the stars aligned and we struck upon some serendipity. Just as we were looking to build our signal primitives for Angular, Wiz was looking at doing the exact same thing. And we were able to say, what?
And to dig more in this, we would like to introduce you to Christopher Rocco from YouTube.
Yeah, hey everyone. So YouTube has been collaborating with Angular and Wiz on the development and adoption of signals for the better part of a year now. and we're currently in the midst of one of our largest ever migrations to Wiz's new reactive rendering system, which is entirely built around Angular signals. And to put that into perspective, so YouTube supports 3 main web platforms today, several apps within each. So we have Living Room, and this is what runs on your smart TVs, game consoles, etc. This is actually running in a browser that we built in-house and serves as like a native app. Then we also have a very full-featured mobile web application that, like Living Room, serves as a native app for a class of low-cost phones with browser-based operating systems, often our emerging markets like India. And then, of course, we have our desktop apps, which includes a massive suite of creator tools. And today, each of these platforms handles rendering differently, with Living Room and mobile web being based on different virtual DOM approaches that we developed in-house, and desktop still running Polymer, which is a now deprecated web components-based framework. Each has its own unique constraints and challenges, so we wanted to know if Signals would be a viable unification target and could help us achieve our performance goals in a practical way. So performance is a never-ending battle. We spend a lot of time on it. We're still not where we'd like to be, and rendering is an important part of that. So first, Signals meet the prerequisites of each of our platforms. They have universal browser support. If your browser supports arrays and closures, it'll support Angular Signals. This is necessary for the custom browser we use to power Living Room. And 2, the bundle size is tiny. It's less than half the size of our virtual DOM approaches, which is perfect for mobile web, where most of our users have slow internet connections. And Signals excel at every synthetic benchmark that we could come up with. So with that, we kicked off some projects to answer the bigger questions. We wanted to know if the performance gains of Signals were scalable to large and inevitably messy code bases and stable over time. That is, once the code is written, how easy is it to regress as various developers are touching that over time? We wanted to know whether we could effectively model all of our existing problems and infrastructure using Signals in a reasonably natural way. And would Signals naturally incentivize better code, or does it require more skill and effort from developers? So we kicked off a couple of projects. We rewrote large parts of the UI, starting with things we thought would be challenging and representative, and the results really exceeded our expectations. So on our low-end devices, we saw 35% improvement on interaction latency on Living Room as you're navigating through video tiles. On our video player controls, we were able to bring all of our key interactions up to a smooth 60 frames per second with very little effort, often up from a jittery 25. On our shorts carousels, you're swiping through videos. We also achieved 60 frames per second, lower interaction latency, and this meaningfully increased our top-line metrics like views and watch time. And then in reviewing that code, we ultimately decided that we did prefer this signals-based rendering model. And there are a few main reasons. And one, it was easier to achieve that high performance. So often developers didn't have to think about performance at all. It was usually the case that the idiomatic way of doing something was also the fastest, even for complex UIs like the 3 that I just mentioned. 2, Signals simplify a lot of framework concepts that were related to the virtual DOM and with Polymer. Things like memoization, stale closures, unexpected re-renders, rules of hooks. And sometimes it was easier to model existing infrastructure, but sometimes it was a bit harder because Signals force you to think more about how data flows through your app up front. But the resulting code is usually something that we would consider more maintainable, and we were happy that we did. So in all, we credit a lot of the viability of Signals to some of the modern features we have that we hadn't seen before. Things like the automatic dependency tracking, automatic cleanups, and the dynamic dependencies, or the self-adjusting property of Signals. So we're already running hundreds of these components in production today, and we're hoping to power all of YouTube's web apps with Signals over the course of the next 2 years. Of course, the explorations lasted months, and they were far more nuanced than I could convey here. But these are the main ideas and where we landed. So if you have questions, you just want to chat, I'm always happy to connect. With that, thank you. I'll hand it back to Minko and Jeremy.
Thank you, Chris. It's really fantastic to see how YouTube is benefiting from using Angular Signals in Wiz.
Yeah, and it's been really validating and confidence boosting for us on Angular to see our Signals library in production at something like Google's or YouTube's scale, seeing that the performance characteristics and the developer experience characteristics are exactly what we'd hoped they'd be.
All right, this collaboration with YouTube has been a huge success for both Angular and the Wiz teams. And this specific project established a model for an ongoing collaboration between our teams. Going forward, Angular and Wiz are going to be working together even more closely, sharing more code. And working together on this will help us year after year to continue making progress on making Angular better for everyone. So after hearing all this great stuff about signals, you're probably wondering how you can integrate signals better in your applications today.
Well, we have great news for you because we have just shipped a slew of new signal-based APIs that you can start using today in your Angular components and directives. We are going to talk about 4 different types of APIs today. All of these are in developer preview right now. And we are going to start by talking about the new signal-based query APIs. So if you've used Angular before, you have probably used queries like viewChild and content-children that let you get references to other components. And these can be a bit verbose.
Yeah, I can see this even doesn't fit on the slide well.
Yeah, in fact, we gotta wrap that. Yeah, so there's a lot there. You've even got that undefined in the type. But now let's look at those same queries using the new signal-based APIs.
That's definitely way cleaner.
Yeah, so these new APIs give you a signal of your query results, whether you're using the singular or the plural version, and you can then use that signal result inside of a computed expression or an effect. And overall, these are more concise, more consistent, and they have better type inference. On top of that, as a bonus, there's also a new feature where you can mark a signal as required. If the query does not have a result, Angular will actually report an error. And this removes that undefined from the type, since Angular is guaranteeing that the result is going to be available.
This is definitely going to help developers to write safer code.
So now for the big one that everyone has been waiting for, signal-based inputs.
Yeah, I remember leaving a lot of comments on the issue about reactive inputs, and happy to see it coming up.
So again, if you've built anything with Angular before, you're familiar with input properties, right? You have some property on your class that you're marking with the input decorator. They are optional by default, but you can pass in a configuration option to make them required. Now let's look at these same inputs with the new signal-based APIs. Just like queries, these values are given to you as signals, so you can use them inside of computed expressions and effects. This can dramatically simplify any code patterns where you may be trying to compute some derived value in your ng on changes or trying to do something when an input value changes. And input signals are read-only, so it's always clear where a particular state is coming from.
Now, since we are talking about inputs, Jeremy, are we doing anything about outputs?
We certainly are, although I do want to make kind of a quick clarification about outputs, because I've seen some common misunderstandings or misconceptions, in that outputs are not actually based on signals or directly using signals. They conceptually work the same way that they always have.
So if outputs are not directly using signals, why are we introducing a new output API?
Well, there's a few different reasons, but there's really just one big one to highlight here, which is that it just kind of looks weird if you're using these signal-based APIs for inputs and queries, and then the decorator-based API for outputs. We want the experience to be kind of more consistent, holistic across the board. So let's go ahead and look at what this output-based decorator would look like if we were to use the new API.
I definitely like this a lot. It just gets rid of a lot of boilerplate.
Exactly. There's less to write. It's more concise. And you can just avoid forgetting about creating new event emitter here, right? Less to mess up. You still emit on this the same way that you always have. OK, so that brings us to our final new signal-based API for authoring components and directives, model inputs. And to talk about model inputs, we need to take a brief aside to talk about two-way binding. So sometimes you want to keep a little piece of state in sync between two different components in your app. Angular has a feature that lets you accomplish this called two-way data binding. In this example here on the slide, whenever the isAdmin value updates, the checked property of this checkbox also updates. And the other way around. When someone interacts with this checkbox, the new value is propagated back to this isAdmin property. In the past, if you wanted to make a property two-way bindable, you had to first introduce an input for that property, and then also introduce an output with the same name as the input with change on the end, and make sure that it emits the output when that thing changes with the same type as the input.
Jeremy, I'll be honest, that's pretty clunky, and I always need to look up the documentation for it.
So, fortunately, adopting signals has given us an opportunity to revisit this API and try to make it simpler. So, let's actually just jump back and forth between these two here. Here's the old way, and here's the new way. We just have a single function model that creates a new type of input, a model input.
I'm much happier with this, for sure.
Yeah. And model gives you a writable signal, so you can update the value directly, and it will automatically propagate that value back to any two-way bindings. So let's go ahead and look back at the example that we looked at earlier, but now with the signal-based APIs. Notice that the two-way binding passes the signal instance rather than reading the value from the signal. In this way, the two-way binding is defining an explicit contract where this profile component is granting access to this checkbox to write new values by directly passing that signal instance. Making this explicit fits into our goal of making your code more safe and predictable. We really think that these new APIs are going to improve your authoring experience for Angular components. Again, they are all available right now in developer preview, the most recent of which, the new output API, was released in 17.3 just last week.
All right, so these APIs, they definitely seem great. And if I start using them today, does that make my application fully zoneless? So can I just get rid of this import from my JavaScript?
Well, we still have some improvements we want to make before we can start recommending that people go fully zoneless. Using the new Signal API is a big leap forward in getting ready for getting zones out of your application, and it has other benefits as well. But there's still some work we want to do to make sure that the experience is as streamlined as we'd like. In particular, how the framework schedules tasks and how you would interact with change detection inside your tests. But we are making significant progress towards that point where we'll have a well-lit path for fully driving UI updates from signals.
So whenever we're talking about signals on social media, we get one question pretty frequently. How does RxJS fit in here? Well, there is another independent project that we're working on. It's a long-term project, and we're slowly moving towards making RxJS optional. Where by optional here, we mean that you can use all these features of Angular that you like, but without strictly requiring RxJS in your bundle. This is why we can simplify the Angular's learning journey in the future, and also we can holistically evaluate how we're using RxJS and be more intentional about it, rather than just sprinkle it around the framework. And this way, you can also ship applications with fewer dependencies. But importantly, for developers that choose to use RxJS, we definitely want to make the experience way better than it has ever been. Our approach for this is to just provide a set of very well integrated APIs that provide interop with RxJS. And you can find them today under Angular/core/RxJS interop.
Yeah, and you've probably already seen the first few APIs in this RxJS interop. These let you create observables from signals and vice versa, providing a way to more straightforwardly start using signals inside of existing code bases that may be heavily using RxJS already. But, Minko, I think that the new output API is really a good example of how we're approaching this for trying to make RxJS optional, but better integrate it. So let's look at this particular decorator-based output. So not everyone may realize this, but the event emitter class here actually extends RxJS's subject class. But this can be kind of confusing because subjects have things like completion state and error state, which Angular doesn't really use for the way that it deals with emitting events. Even more surprising, we discovered that people were using patterns like this, creating an output not with an event emitter, but with some arbitrary observable.
Honestly, I'm very surprised that Angular was designed to support that.
It actually wasn't. We've seen people using this pattern in production, but it has only ever worked by pure accident. So, in thinking about this goal of making RxJS optional, but better integrated, we created the new output API without strictly depending on RxJS. So instead of creating an event emitter, it creates what's called an output emitter ref. You still use it mostly the same way that you always have. But we also created some more APIs. So if you want to create an observable from an output, there's an API for that, output to observable. And for the scenarios where you want to emit an output based on some existing observable, you can use the new output from observable function, which adds official support for something people were doing that only ever worked by accident.
Just to recap, the work we did on outputs was motivated by signals, and it also enabled us to remove the direct dependency on RxJS in the framework. While at the same time, we added all these helper functions, which allow you to use RxJS even more fluently in your code. And all of this allows us to be more explicit. You can be more explicit in capturing your intent with your code. So that said, Jeremy, what are we doing to help developers use these APIs correctly?
Yeah, so it's a lot of new APIs, a lot of changes. With all of these patterns, we've been trying to use the Angular compiler to help you catch common issues ahead of time. So for example, the compiler's extended diagnostics can now detect if you're reading a signal in a template without actually using the signal's value, right? And this is especially important in control flow statements like if, where the signal itself is a function and is always truthy, and you may not realize that you're forgetting to read the value out of it.
So talking about debugging tools, in version 17, we also shipped inspection of your application's injector tree. And you can preview each single provider declared inside of your injectors. We actually promised it here at Conf as well, and here it is. Additionally, you can go to your component explorer, you can select a component, and you can preview all the dependencies of this component and see to which injector their associated provider belongs to. And while talking about developer tooling, we improved the type narrowing in templates, so you get significantly better type checking. In version 17, we introduced probably the most significant syntactical change in Angular since version 2, which is this new control flow. And we're really intentional when we're introducing such major syntactical changes because, well, these are APIs that you interact with every single day. Let me walk you through how we decided to make this change and how we executed it. So first, we're running some user studies. We wanted to check whether the signal-based APIs that we were building were actually ergonomic at all. We wanted to see how developers experience it with them. And we've had a group of people with different levels of background, with different levels of experience as well. We had some React developers, Angular developers, Vue developers, from junior to senior, and we asked them to implement a small Angular application. We saw that all of them struggled with control flow. They were not able to loop over a collection of items just because the star ng4 syntax could be confusing. Honestly, I have to look it up often, even though I'm working on Angular. So we figured out that we should probably update this. We should update the syntax and make it closer to JavaScript. And we ran an RFC with a couple of proposed syntactical variations for control flow. And we got a lot of great comments. One of these comments proposed an alternative syntax to what we were thinking, and the community really loved this proposal. We liked it too, and we evaluated it. We, in fact, ran developer surveys comparing the different syntactical variations, and about 12,000 people responded to the survey, unanimously liking the community proposal, which we ended up also implementing.
Yeah, so we're really happy that the new control flow is significantly more intuitive and closer to JavaScript syntax. It makes it trivial to use patterns like else if, and it gives you better type narrowing. And best of all, you can automatically refactor your code to the new syntax using the Angular CLI. And while we were introducing this new syntax, we also used it as an opportunity to improve the list diffing algorithm that we use for loops under the hood. This allowed us to improve performance in some scenarios by up to 90%. It also positioned us very well in the relevant JS framework benchmarks.
All right. We're really surprised by some of the results as well. After build.com, they started using the new Angular control flow. They saw 1 second improvement in their LCP in all of their pages. And even though the control flow is still in developer preview until version 18 this May, you can still give it a try. And you can use this automatic migration with the Angular CLI with just running ng-generate at angular/core:control-flow, and it will transform your projects automatically. It will just move your ng-for and ng-if and ng-switch to the new control flow, and you're going to get also the performance boost.
Yep. Yes. And the performance gains we've seen in control flow are honestly the least of what we've been up to on the performance front. We've talked about some of the performance things we were doing last year during the keynote, and we've made a fair amount of progress since then. Recently, with the help of Chrome's Aurora team, we shipped some improvements to Angular's image directive. Now, in case you're not familiar with this, you can import ng-optimized image and apply it to an image element by using ng-source instead of the source attribute. When you do this, you're enabling several performance optimizations under the hood that help improve your core web vitals. In particular, we've recently added support for image placeholders, automatically generated pre-connect links, and preload hints for SSR. We've seen some evidence that this feature meaningfully improves core web vitals. In particular, in some e-commerce platforms, we've recorded improvements of up to 75% in largest contentful paint. So make sure that you are using this directive. We highly recommend it.
All right, so last year at Conf on stage, Jessica opened an RFC for a declarative lazy loading and prefetching of code. We shipped it in version 17, and it is now available in developer preview. It pretty much allows you to extract part of your template and all the transitive dependencies in a separate chunk, and declaratively just specify prefetching triggers. So on demand, you can download code in a way more ergonomic way. So how many of you like live demos? I love watching them too. I'm like, all right, so let's see if this is going to work. We're going to just run ng-serve. And when I open the browser, I see this very simple application. Just have a chat box right here. So when I open Angular DevTool, actually Chrome DevTools, so you can see I can just type stuff in the chat box. Nothing too much happens. When I open Chrome DevTools and look at the Network tab, we can see that the chat box is loaded eagerly. And if you have visited an e-commerce platform, you know that maybe 1% of the time you would engage with this chat box, right? So this code is just unnecessarily blocking, like making your application slower. With deferrable views, we can very easily load it in a different way. So we're just going to specify defer, specify a trigger, wrap our chat box, and add a placeholder. So here we're specifying that we would like this chat box to start loading and get rendered once the placeholder enters the viewport. When I save this, we'll see that in the main bundle, we don't have the chat box present anymore. And when I expand the chat box, it is going to get lazily loaded. So yeah, thank you. So you can see that deferrable views, they handle a lot of the complexity under the hood. They figure out different loading states and also interactions with intersection observers. So if we expand these 4 lines of code, well, they're saving you typing of maybe a couple of hundreds in order to make sure that this is out of issues. Companies are using this in production, in fact. Build.com reported that for one of their applications, they reduced the bundle size with 50% by using deferrable views. So I recommend you to give them a try.
So talking more about performance, one of the most important techniques that you can use to optimize your largest contentful paint is by using hybrid rendering. And by hybrid rendering, I'm talking about any sort of mix of server-side rendering, build-time pre-rendering, and client-side rendering. In version 17, we noticed a significant jump in the adoption of server-side rendering and build-time pre-rendering with Angular. In v17, the number of applications in HTTP archive using SSR and pre-rendering increased by over 37% compared to v16, and we've seen developers benefiting from it. For example, Virgin Media O2 saw a 72% reduction in their largest contentful paint after switching to Angular's hybrid rendering, and there's been a correlation observed between these improvements and increased adoption.
In version 17, we released the developer preview of our ESBuild-based builder, which entirely replaces Webpack. For the experience during development with ng-serve, we're using Vite because of all fantastic properties that it has, including fast cold start. So let us explain a little bit more how this works.
Yeah, so if we look at an application with server-side rendering, we'll see that the ng-build command calls the Angular and TypeScript compilers directly to type check and produce JavaScript for both the client and the server. From there, we pass these entry points to ESBuild, which knows how to produce your final bundles using the output optimized by Build Optimizer to further reduce the size of your bundles.
After switching to ESBuild, Vanguard saw 3 times faster production builds for one of their applications. And we made the ESBuilder the default in version 17. You can migrate existing applications to it by using an Angular CLI schematic. You can find that at angular.dev.
Yeah, and talking about your kind of local developer build, we've seen a lot of benefits from powering ng-serve with Vite. We've added a Vite plugin that introduces some custom response resolution in order to make it way easier to do local development with server-side rendering. So this plugin, based on the page that you're viewing, that can take a different code path. So if you're looking at a page that uses server-side rendering, it will server render that page and deliver it. If you're just looking for a static file, it will just return that. And for JavaScript bundling, it will lazily produce the JavaScript bundle based on that specific page. So you don't have to spend extra time waiting for the dev server to process the JavaScript that you don't need for that page. We know that having a fast edit refresh cycle is critical for your productivity.
So there is one more interesting observation about this chart, and it is specifically around the adoption of hybrid rendering. So last year at Conf, we announced developer preview of hydration. If we zoom in into the version 17 adoption of hybrid rendering, we'll see that 76% of version 17 applications are already using hydration in production, and they're benefiting from it.
Yeah, looking at HTTP archive again, we see that applications have been benefiting from hydration with about a 200 millisecond reduction in their largest contentful paint in the 60th to 80th percentile.
So just a quick reminder of what hydration is and how it works. When your device sends a request to the server is going to render your application, return HTML, and it is going to have a bunch of reference JavaScript that your browser is going to download, parse, execute, and make your application interactive. There is one common issue when the server returns an HTML which differs from what the browser expects.
Yeah, and you can sometimes have a hard time debugging this situation where the server and the client don't exactly agree on what the page is supposed to look like. But to help with this, we've introduced a new feature in Angular DevTools that can help you identify and debug this kind of mismatch.
So there is also one more thing about full app hydration that could be further optimized. Remember the collaboration we have with Wiz that we talked about earlier? So as a reminder, Wiz is laser focused on performance, and they offer an improvement over full app hydration. So you don't have to download all this code ahead of time. What you would see on a high level is at the beginning, the device still sends a request to the server. The server will respond with HTML. But at this point here, we are not downloading all the JavaScript associated with your application or the framework. We just have a very thin event delegation layer that can handle user events on a top level, look at the event target, find an identifier, and from there, based on this identifier, download code that is responsible for handling the user events. So this way, you can significantly improve your core web vitals and reduce the initial bundle size of your application. Now, Angular was not originally designed with this in mind. We're really excited about this idea, but Angular was not originally designed with this in mind. So
we were just talking a little bit about that event delegation library, right? And about full app hydration. And full app hydration is great, but everything has to be done eagerly, right? So we're going to show a little demo here of a thing we've been working on that I'm quite partial to. Yeah, it's partial hydration. So what we're going to show here, which I think is already kind of running a little bit. So we'll start this over. There's a couple different colors of what you're seeing on this screen. There are gray outlines. Those gray outlines, I'm still a little out of breath from... I need to work out. The gray outlines that you'll see, that means it's dehydrated content. The blue outlines mean it's hydrated. If you see orange here, that means that it is currently being fetched and not yet finished loading. So as we go through this, you'll see those outlines and just know that we added a bunch of artificial delays. So that's why it's like taking a couple seconds before things change. It would be much, much faster in production. So.
And this is a video of a real app, right?
I didn't hear that. What?
This is a video of a real application,
This
right?
is a video of a real application. This is a video of a real application. So as we start off, it's all gray. And then the outline, the outer elements turn blue, they hydrate. And then as we interact with the elements, like the details element here, it suddenly loads, fetches, and then hydrates. And then we can interact with some of the remaining dehydrated content, which then gets hydrated. And some of it's still left dehydrated. And then here, what's happening is that, what if you clicked that button 4 times before any of it actually loaded? Well, we just wait and replay that. So you can see there's 4 items in the cart after clicking that button 4 times.
That was a huge surprise. I didn't expect to see a live demo of partial hydration. When are you expecting this?
When are we?
Just later this year?
Say something.
Later this year?
Later this year. Later this year. Yes. So I guess same time next year?
We'll see.
Okay. See you, everybody.
Thank you, Jessica.
All right. So once more, that talk from Jessica and Doug is what's cooking with SSR in Angular. And it's worth mentioning, if you are using SSR with Angular, you're going to need somewhere to host and deploy your app. And we want to highlight that you can do this on really any hosting provider that you may consider, things like Firebase, Netlify, Cloudflare, whether you're doing client-side rendered, pre-rendered, server-side rendered, all of it can work in multiple different hosting providers.
So with all this innovation happening in Angular lately, we have been also seeing a lot of advancements in the community. For example, popular state management libraries already introduced signal support.
Yeah, and we'd like to congratulate Brandon Roberts on the 1.0 release. The 1.0 release of Analog.js, a community-driven Angular meta framework. One really interesting aspect of Analog is the alternative component authoring format. This lets you... Yeah, they like it. This lets you build Angular components as a single file component, similar to something like Vue in Svelte. We think that this is a really cool thing when the community explores ideas like this. And we've had a lot of conversations on the Angular team about the friction points with the current authoring experience and what we might do about that. And it's clear that Brandon has seen a lot of the same problems and is thinking about the same kinds of solutions.
Another piece of community work that I'm really excited about is the 10-stack Angular support. So big thanks to Chao and Arnold for bringing 10-stack query and store to the Angular ecosystem. I've also heard that later this year you may see even more of 10-stack in Angular. So Jeremy, we have been evolving the framework fast, and Angular is turning into one very future-looking framework, and one thing has been bugging me. This red shield is just so 2010 or so. Just
yeah.
HTML5 for HTML5 days.
Yeah, we've had this logo, but effectively in some form or another, for over a decade.
Yeah, we removed the border at one point.
So you think maybe it's time for a slightly new visual look?
Yeah, in version 17. We worked on reflecting the future-looking nature of Angular and its visual identity as well, and we did this visual branch refresh.
Right. But the logo is really the smallest part of what we have been working on as part of that refresh. In particular, we have built a brand new documentation experience at angular.dev. This is currently in beta. You can visit the site right now. And we plan on making this the one-stop shop for all Angular documentation in V18 with a number of improvements to the way that information is laid out and new features for being more interactive with angular.dev.
Definitely, yeah. For example, we have an interactive getting started tutorial, which allows you to use step-by-step the individual features that we just talked about in the browser with StackBlitz web containers.
Yeah, so as always, one of the pages that you might visit on angular.dev is our roadmap at angular.dev/roadmap. We try to be pretty transparent about the things that we have coming up. But we also wanted to highlight a couple of things. So, our backlog on Angular is effectively infinite, right? I'm sure some of you can relate to that. But we've cherry-picked here a few exciting things near the top of that backlog that we really hope to work on over the next year. Things like full zoneless support, hot module replacement, streaming SSR, and component authoring improvements, just to name a few.
So the way we built Angular is incremental. We just make small incremental steps in order to gradually evolve the framework. And we're applying the same to the authoring format. When we start talking about authoring format, well, this is a pretty sensitive topic because this is still the interface that you're interacting with Angular every single day. And we are planning to make incremental, gradual changes so that we can remove the boilerplates and further improve your efficiency with Angular. So just wanted to show you what standalone components may, for example, unlock. So look at this example. We have two standalone components, the app component and the zip component. And the app component is importing the zip component. But they're already in the same file, and these selectors seem a little bit redundant. So rather than using the selectors, we can directly reference the JavaScript symbol in the template. See how this zip got capitalized there? And this makes the import here in the component metadata redundant as well. So we can just remove it. And when we flip the default of the standalone flag from false to true, we can remove it as well. And this gives us significantly simplified single-file component authoring experience. So this is still a work in progress. We don't have even a design document for it yet. And yeah, thank you. We need to decide what we're going to do with directives and pipes. And we're going to obviously follow up with an RFC so that we can collect people's feedback on the direction. Before we end this keynote, we do have one more very highly experimental thing that we would like to mention.
Yeah, we know that AI is getting a lot of attention right now, and we think there's actually some real potential for making Angular developers more productive, especially with Google's Gemini.
So with Gemini, we have been thinking how it can make user experience better and developer experience better. There are already really good developer SDKs that allow you to use Gemini in Node.js or even in JavaScript. Just make sure you keep your secrets a secret. So Emma and Mark are going to share more with you about how are we investigating to improve developer experience with Gemini.
We are going to talk about Angular and Gemini. So Angular developer relations and the team as a whole is always thinking about how we can improve Angular for the community. All of this work we've talked about today is really for you. And with the rise of AI, we've been considering thoughtfully how we might combine AI with the power of Angular to improve Angular's developer experience. So we're here to talk about two experiments. And before we get started, these are just that, they're experiments. So we don't know what will happen long term. But we're delighted to be pushing the boundaries and experimenting along with everybody else in the developer community. And we started by asking ourselves a few questions. So what if we could ask Angular.dev a question? Angular.dev was a significant step forward for how developers are learning modern Angular. It documents all of those new things, defer, control flow, hydration, all of these new words that new developers and old developers are learning all alongside. And all of those docs are being written by really smart people who know these topics way better than us. So we thought, what if we leverage the domain-specific knowledge of Angular.dev without having to train a custom model? So if I ask, what is a signal? I don't want to learn about traffic signals or something unrelated. I want to learn about Angular signals, and I want to learn about the latest thing happening in Angular signals, like model inputs in v17.3. Or if I ask about hydration, I don't want to learn about rain clouds or how water works. I want to learn about what Jessica and Andrew have to say about partial hydration in the latest version of Angular. And right now, AI models generally aren't super great at knowing like the expertise of our team. So alongside Google Labs, we've been researching methods for making a technical documentation specific chatbot, like you're seeing demoed here, and directly embedding that in Angular.dev. So right now, we're researching and prototyping with some complex topics like retrieval augmented generation, or RAG, semantic retrieval, a lot of sort of experimental APIs that Google is coming up with as they're shipping them. And we're excited to be bringing this to developers and prototyping with early access programs to just see if this is helpful for you and if this makes it easier for all of us to learn modern Angular development. But that's not the only question we're asking. What else are we asking, Mark?
Well, so here's a different experiment that we're working on right now. So we want to ask the question, what if the Angular CLI and just the tooling in general could generate custom components for you? Now, we know that we have schematics already that can generate components and other code, but if we wanted to make it more custom, that would actually cause our engineers to have to take on that burden to continually expand the scope and the API surface. But a different way to think about it is, what if a large language model could do that for us? What if Gemini could help us actually create custom components that you could describe yourselves? So we started investigating, and it's been really interesting. So the first thing we tried to do was to prompt our way to success. If you use Gemini or any other large language model system, you've seen that you just keep trying to get it to give you what you want. So here's what we found when we first tried this. First thing we noticed is that the code was missing some of the newest features, like things we talked about today. It doesn't know about output yet. It doesn't know about some of the signal stuff that we're doing. And then the second thing we noticed is that the format was inconsistent. So sometimes we get a component that had an inline style, then sometimes we run the same prompt and get a component that had an external style. And then sometimes we get it where it had an internal and external, it had both. Okay, none of that makes a lot of sense, right? So we were trying to figure out what to do. But here's the biggest issue that we learned. Sometimes the code had errors, and you can't include that in your project, right? Sometimes imports are missing. Sometimes there's some type checking errors. So that created a different problem for us. Here's what we decided to do instead. Yeah, we just made the prompt longer, right? Like anybody's done that before? You just keep making the prompt longer and longer, but guess what it ended up creating? The same problem as if we tried to expand the schematics. I was writing prompts to try to cover every edge case, and then the prompt got so long that it didn't make a lot of sense. So we learned, and we got a little bit better, and we tried to prompt better. So when it comes to prompting in general, there's prompt design, and then there's prompt engineering. Prompt design is that where you just kind of describe what you want. Prompt engineering is where you try to get more accuracy and better performance. One way to do better prompt engineering is if you use few-shot prompting, where you say, well, here's the prompt, here's what I want, but also you provide examples of here's the right solution if you come across this type of prompt, okay? Now, this got better, but there is still more for us to learn. All right, friends? So while we did get some better things, again, like I said, there's more for us to learn. Here's what we're thinking about overall when it comes to all of this. We don't want to force a solution on you, right? We want to find something that serves the community, that serves our users. And so we're going to keep learning, we're going to keep experimenting, we're going to keep trying, and we're going to tell you all about it as we learn more. Thank you so much.
Thank you so much, Mark and Emma. So That about wraps it up for the keynote today, but I do want to go back to what we mentioned at the beginning of the talk before we leave you. Again, our mission with Angular is to help you deliver web apps with confidence. We have talked today about all of the performance-oriented features that we've been working on in server-side rendering, hydration, partial hydration, deferred loading. We've talked about the developer experience things we've been working on in terms of signals and our browser extension dev tools, our CLI dev tools, right? Things that are going to help you build faster. And everything that we're doing is incremental. It comes with migrations when possible, and we try to keep the framework as stable and reliable so that you can take advantage of these new things without any real disruption to your flow.
Thank you all, and looking forward to chatting with you over the next couple of days.